Greetings. In this episode we're going to continue to go through some TRS-80 components I recently picked up. In our last episode we looked at a bunch of monitors and got two working again. And today we're going to look at some actual computers like this. This is a TRS-80 Model 1. This has been upgraded to level 2 ROMs, and the memory is upgraded to 16K, and it had kind of a weird problem. The problem was that you turned it on and nothing happened. I mean, nothing. It seemed to be completely dead. I noticed that the power light came on briefly and then went off again. So I figured, okay, we got a power supply problem. So it's not a switch mode power supplies. So, I mean, they don't act like that when they go bad. They either don't work at all. When you turn them on, they don't supply the right voltages, or they do work. But this one, you turned on and the light came on briefly and then went off again. Then I realized that I had both the monitor and the computer hooked up to a power strip. So when I flipped the on switch, the light came on. I didn't see anything on the screen, and then the light went off again. But then I realized, since I was switching them both on at the same time, the CRT needs a warm-up time. So even if it did put something on the screen, you couldn't see it because the CRT wasn't warmed up yet. So finally I turned on the CRT, and when I turned on the computer, it has a simple push-button on-off toggle switch. It briefly put up a legible message, and then it shut off. So again, it looked like there was something wrong with the power supply. I started filming it, and then I realized that what was happening was, when I hit the power switch, as you're hitting it, okay, it was on, so now it's off, it clicks, and then you let go and it latches in the on position. And upon further investigation, I saw that the power switch lost continuity when it latched into the on position. So it looked like all I had to do was get a new power switch, and I'll show you later on what they look like. They're these big switches, yeah, you just replace the power switch and that should fix things, because I did see a legible message on the screen, but then the switch refused to function. So I decided to try something first, and that was the following. But maybe, just maybe, I could get lucky and fix this thing on the spot. And here's a power switch. You press it. Let's see, now it's off. Press it again. It clicks, and when you let go, it latches in the on position, and vice versa. So I said, okay, before ripping this apart and spending large amounts of money on a switch, let's try one thing, and that is, let's use isopropyl in a solution bottle. And the switch is kind of open frame inside. What if the switch is dirty? What if in the latched position it hits a dirty part of the contact and just doesn't conduct? So what I did was I put this upright and then squirted in a bunch of IPA, isopropyl, into here, right around the button that I press. I held it up for a while, let the alcohol sink in, hopefully do its job, work the switch a couple of times. And this is what happened after I waited patiently for a few minutes. This time I turned on the monitor first and left this off, giving this enough time to warm up. And now, when I press the power switch, it works every time. You know, you can play around with the switch, move it around a little bit, press it slightly so it doesn't unlatch. Fixed it. So there was something right on that part of the contact that closed. The part of the contact that was actually engaged when the switch latched into the on position. And it was a pretty simple fix. I didn't really film the whole procedure, but I thought it would be interesting for you to see that it does happen that power switches go bad, and I've actually seen it a lot, mostly on arcade games, where the main power switch just doesn't work anymore. It clicks, it looks fine, smells fine, but it doesn't work. And so we finally found one on a TRS-80, a no parts fix with a few squirts of IPA. And on I went to the next one. That one was fixed. I tested it a little longer, and it was fine. It was just a dirty power switch. This one, though, is another one, and that seems to have an actual problem, an interesting one, hopefully. So when we turn this on, it loses, it's not generating a sync signal. I can't yet tell, if I stare at it, I can't see if it's trying to put up any text. We can see the characteristic garbage screen appear that happens on all TRS-80s when the video circuitry starts to run, but the CPU hasn't started to run yet, and it's just displaying random data from the screen, from the frame buffer. And it looks to me, if you look closely, when I first hit the button, you will see a screen of garbage characters. So 3, 2, 1, go. But it disappears immediately, and it does this. And to my untrained eye, it looks like the vertical sync actually isn't working right, because you can't adjust it. Well, you shouldn't have to adjust it because it worked. This is the same monitor we used with the first computer, so this should work. So let's tear down this guy. It's interesting to note that, this is a level 2 ROM revision on it, which they couldn't fit into the 2 provided sockets that were originally designed into the board, so they put on this daughter board here with 3 4K mask ROMs and a decoder chip, and the ribbon cable runs into one of the original ROM sockets, and that's how they upgraded the ROMs on these. Also, this one, for those of you familiar with these, did not have the numeric keypad that was normally on machines that came with level 2 ROMs installed from the factory. So when you see a level 2 TRS, when you see a Model 1 level 2 that doesn't have the numeric keypad over here, it's an early version that started its life as a level 1 ROMs, kind of tiny basic with 4K, and then had the ROMs upgraded and the memory upgraded from 4 to 16K. So here's the board in the service position. You take out the stack, the keyboard and the CPU stack. The keyboard to CPU connection is a permanently soldered flex wire here, and these do become problematic because the internal connectors at the bends here start to crack, and that you'll start losing certain keys on the keyboard because they can't communicate properly anymore. But yeah, this is the board, and it makes it somewhat simple to work on. Here's a view of the power switch over here. this monstrous switch just to turn things on and off. Here's the button from the outside, but it's not hermetically sealed. It's open at the ends. Don't know if I can show you that. Well, you can kind of see it where the shaft of the button enters the switch body, near the white spot, near the white plastic there. It's open. That's how dirt can get in, but obviously that's also how we can get the dirt out, which worked on the last one. This doesn't have that problem because it comes on, but it only shows us garbage. So before jumping in, let's just make sure that it's still true. And we can see it's acting the exact same way with a problem on the VSync. Looking at the relevant part of the schematics, basically the bit clock, we're looking at this block which digitally generates, and as you can see, the video signal, and this signal is actually labeled sync. And it comes out of here. I mean, it's labeled sync because that generates the horizontal and vertical sync, and over here is where the bit clock comes in. So the vertical and horizontal lines go into the horizontal drive, and the VDEV, they call it. It's the horizontal sync and the vertical sync here. And it's run through two inverters. Then they have adjustments here for horizontal and vertical position. Then they have something here that I would call a poor man's pulse generator, because using these two inverters back to back and then putting a cap from the input to the output generates a pulse. This, along with this capacitor, along with this, will generate a pulse over here rather than just following the input. They're identical circuits. They got slightly different capacitances because it generates a different pulse width, but the long and the short of it is that when this signal changes from low to high, what you see at this output here is just a single pulse, and the same here. And then this combines it, the horizontal and vertical together, and generates a sync signal. And there's something wrong in here. That's my guess. Now, one thing that these are actually notorious for is they used a 74C04 as the inverter. That is the TTL pinout. It's the same as a 74LS, the pinout is, but it's a CMOS part. But instead of using an actual CMOS part, they used the 74H part. This was early on, and these parts were not very reliable. So if we start probing through here with the scope, we should be able to find if one of these went bad. They are CMOS chips. Don't let the 74s fool you. And these are early, late 70s vintage chips, and I've seen these go bad before. So I just probed that section of the schematic I showed you, and when I got to Z57, which is right in the middle of the vertical sync generation circuitry, saw a signal that looked okay, and then I saw a bunch of garbage. Floating signals, floating again. This chip does not seem to do what it's supposed to. Now something seems to be making its way through, but we're at 2 volts per division, so it's probably the right shape of the VSync signal, but it's way too weak, and that's what would cause the monitor to behave that way. So the chip probably needs replacing, but I'm going to try an old trick as follows. So you're looking at the bad chip over here, and what I'm going to do is turn it off, take a known good chip and put it on top, and hopefully that'll make good contact with it. And if the good chip is stronger than the defective one underneath it, seems to be there. It's not secure, but it's a great way of checking whether you're on the right track or whether you're going to be removing a chip that is not the problem. Even though on that chip internally, it's internally connected, as you saw on the schematic, one inverter of the same package feeding another one, and those lines were floating, they were low, they didn't look too good. One last visual check to make sure that at least it looks like all the pins are connecting to the old one. And they seem to be, so let's bring the monitor into play. And test our diagnosis. So we are there, everything's in place, and power on. Yep, that's what it was. Does it see all the memory? Oh, that keyboard's bouncy. Yeah, that's about right. The difference between this number and 16K is basically the room set aside by the ROMs for level 2 basic. Best, but it looks like we're going to have to go in and replace that chip. Now, if you were in a real rush, what you could do is basically tack solder that guy onto the bad chip and everything would be hunky-dory, right? Wrong. Eventually the bad chip would probably kill the new chip on top too, and we don't repair things like that. So let's fire up the desoldering gun and replace that chip. So this got replaced over here. Of course, the ROM board was covering this, so I had to use my superhuman strength to break the seals of 40 plus years old double-sided tape. But if you look at the chip, it's both marked a 74C04 as well as a CD4069. So it really is a CD4069, and it's just, they just printed another type on it. Why, I don't know, but again, you see a 74C04 of 70s vintage, suspected immediately. So yeah, let's put it together. The new chip is in over here, and I reattached the ROM board with a brand new double-sided tape. So now we can put the whole thing together. But there is one thing I want to point out to you that to me is a serious implementation defect on these, and that are these connectors over here. This one's power and this one's video. The problem is they are both 5-pin DINs. Here's power, here's video. So what I'm getting at, wire colors are kind of similar. It's very easy to plug video into the power connector, which is, which is okay. That's not going to hurt anything. But you plug power into the video connector, and you're going to take out the video circuitry in here. And I bet you they had to deal with that a lot. But, how much did you save? You should have, in my not so humble opinion, the power connector should not have used a 5-pin. Could have used a 4-pin, could have used a 6-pin. That way you would never be in a situation where you could plug power into the wrong place. Oh yeah, the last one is a cassette connector. And that's also a 5-pin DIN. So, yes, I would consider that a serious implementation problem, but the 17.5 cents they saved on each machine, having 3 identical 5-pin DINs, probably made the stockholders happy. Okay, looks like the patient has been healed. Works fine. The keyboard's a bit bouncy, but and what I'll have to do for that is probably remove all the key tops, spray the contacts with alcohol, and hope that fixes it, or just do a whole lot of typing. That also cleans the contacts a bit and lessens the bounciness, but you don't have to worry about that. That's something we'll attend to. That's something I'll attend to soon. Thanks for watching. Please like and subscribe, and we'll see you next time.